Welcome to Cheenta School of Statistics and Data Science. Today we are going to solve question number 58 of GATE 2022 statistics paper. The problem says that a random sample of size 5 is taken from the distribution with the probability following probability density function fx theta equal to 3x squared by theta cube for x lies between 0 to theta and 0 elsewhere. And here theta is an unknown parameter. We also have the observed values of the random sample as 36475, the random sample of size 5, and this is the random sample. Then we have to find the maximum likelihood estimate MLE of the 1 by 8th quantile of the distribution. So to find the required MLE of the parametric function, let us first find the MLE of the parameter, the main parameter of the underlying family. So to find the MLE of the parameter theta, we have to first find the likelihood function of theta given the sample values. So the likelihood function of theta is as follows: 3 by theta cube whole to the power n, product of exercise I equal to 1 to n whole square. For each exercise lies between 0 to theta, I equal to 1 to n. Here n is the sample size. We have taken the sample size to be n here. We will put n equal to 8 later. So the likelihood function becomes 3 by theta cube whole to the power n into product of exercise whole square. Indicator function of x order n lies between 0 to theta. So we have considered the x order n statistic because x order n is the maximum. And we have the condition that x1 less than theta, x2 less than theta, up to xn less than theta. So to incorporate all the conditions in a single condition, we have taken the maximum order statistic. So maximum order statistic less than theta, we automatically imply that all the xi value are less than theta and greater than 0. So now look at the likelihood function of theta. It is a decreasing function. You can check that L theta 1 given x curl less than L theta 2 given x curl for theta 1 greater than theta 2. You can check it. So as L theta is a decreasing function of theta, for theta lies between x order n to infinity because the parametric space of theta is greater than x, and here we have considered x order n. So the parametric space starts on x order n and it goes beyond up to infinity. So if we draw the curve approximately, here is a theta and here is the L theta. So we observe that here is x order n. It is starting from here, and from here the function is decreasing. So the maximum value of L theta x is obtained at this point, which is the point at x equal to x order n. Hence theta equal to x order n is the maximum order is the MLE of theta from the definition of MLE. So we have obtained the MLE of theta is x order n. Now let Tp be the pth quantile of the distribution of the underlying distribution or the given distribution. So from the definition of quantile, we have integration over the PDF, integration over 0 to Tp of the integrand is the PDF. This will yield the probability P, because the pth quantile means, say Tp is a pth quantile means probability of that x less than equal to Tp is P, where x is the underlying distribution. So this is the definition of pth quantile. So from the definition, we get Tp equal to theta into p to the power 1 by 3. Here Tp is our pth quantile. So we have obtained the pth quantile as a parametric function of the given distribution. So put p equal to 8 because we need to find the 1 by 8th quantile. So pth quantile means 1 by 8th quantile of the distribution, and hence Tp becomes theta into 1 by 8 whole to the power 1/3. That is become theta by 2. So now we have to obtain the MLE of theta by 2, which is a parametric function of the given parameter theta. Now we have a nice property which is called invariance property. What is the property? What does the property tells us? So it tells that if T is MLE of a parameter theta, and f is a function of theta, then ft will be the MLE, that is maximum likelihood estimator of the parametric function f theta. So mathematically, if t is a MLE of theta, then ft will be MLE of f theta, provided f is a function. Okay. So applying that property here, the function is f theta equal to theta by 2. So eventually x order n by 2 will be the MLE of the pth 1 by 8 quantile of the distribution. So we have written that here using this property. We have the MLE of theta by 2 as x order n by 2. Now we have the sample values as 36475. So the maximum likelihood estimate of the 1 by 8 quantile will be the observed value of the maximum likelihood estimator. So that is the maximum value is here is 7. So that is the estimate is 7 by 2, 3.5. Hence we have the maximum likelihood estimate of the 1 by 8 quantile of the distribution is 3.5 rounded up to one place of decimal. So that is all for today. Thank you for watching. I will see you in the next video. Till then, stay blessed and stay tuned.